This is StarTalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. This is a Cosmic Queries edition in the coronaverse as we continue to have our guests join us from wherever they are in the universe. But first, I got my co-host, Chuck. Chuck, nice.
Hey,
How you doing, Chuck?
What's happening? I'm actually having breakfast, Neil. I'm having breakfast.
Oh, okay. That's very nice.
Yeah.
That's more than I cared to know about you this morning, but that's fine.
I know you don't care about my nutrition.
That's fine. You're tweeting at Chuck Nice Comic. Always good to follow you there.
I am.
And so today's Cosmic Queries is on a topic we have yet to really jump into. Ha, ha, ha. We're talking about volcanoes.
I see what you did there.
You see what I did there? Wasn't that clever of me? Okay, now, none of us have any such expertise. So we combed Earth to find, and there are a few of them out there. I think they're called volcanologists. And we found one who works with the Smithsonian Institution in Washington, D.C. And welcome, Janine Krippner.
Thank you very much for having me here. First of all, please don't go jumping into volcanoes.
Okay,
I do not recommend that.
Try not to.
But Janine, how else will we appease the gods?
That is an important question. Clearly, for 2020, we have not been appeasing the gods for a while. So I'll get back to you on that.
So you're a volcanologist, which has to also mean that you're fundamentally a geologist. Is that correct?
There are different types of volcanologists, so gas, physics, but yes, I am a geology-based volcanologist. So I look at a lot of rocks.
A lot of rocks. And the Smithsonian Global Volcanism Program, like, what is that?
So it's this really neat program where we're basically recording and keeping track of the world's volcanic eruptions.
I'm glad somebody's doing that. That's right? Good. Okay. Thanks for letting us in on this fact that somebody's taking care of business. Okay.
Yeah, no, there are volcano observatories around the world. They do the day-to-day monitoring and we're trying to make sure that communities are safe, but we collate all of that data so that we have this wealth of knowledge about volcanoes so we can look back and study them and look for any patterns or have a better understanding of what volcanoes do.
So how many volcanoes are being actively sort of monitored at this moment?
Oh, actively monitored, I don't know. But do you guys know how many are actively erupting today?
No,
we don't.
What's your guess?
I'm going to say too many. That's my guess. That's where I'm too many.
Volcanoes.
That's where I'm going.
Okay, I'd say 150.
44 ongoing eruptions, but there are over 1,400 volcanoes that we consider to be potentially active. So that means they've erupted within the last 10,000 years, so in the Holocene. And that's a baby for a volcano. That's not very
so the
long
Holocene is that what we're now calling our time, the time of civilization?
I've been on the fringe of the debate on that. But Holocene is the last 10 to 12,000 years.
So that's when humans have had agriculture and when we've been sort of doing our thing, creating civilization, right?
Well, we base it, we use that age because in the Northern Hemisphere, that's when a lot of the ice sheets came down and actually removed a lot of the recent, before that, records of volcanic activity. So from 10 to 12,000 years onwards, we have a much better record of what volcanoes have actually done.
Oh, I see. So the Ice Age wiped your slate clean.
A little bit.
Oh, okay. Gotcha. Interesting.
Gotcha. So now where do you stand on the Anthropocene? I'm just curious.
You're trying to pick a fight.
That's why I asked the question.
Chuck, step away from the microphone. Step away from the mic.
As their spokesperson today, they would ask us to stop polluting the planet, but they don't care about that.
Okay. Actually, that's a whole other show, Chuck, talking about the Anthropocene. Yeah. So with volcanoes, so I came up with the number 150 because I think there's active ones and then there's but then there are ones that like could blow at any moment. Was that closer to what my number would be? Maybe.
So the ones that could start an eruption anytime would be that 1,400 plus volcanoes. So while they might not be showing any signs of erupting today or tomorrow or even next year, that can change very quickly. So we have to prioritize somehow which volcanoes we're going to put our resources and our monitoring into. So that's a good start, is looking at, okay, which ones have erupted recently, which ones have young magmatic systems underneath them that might start anytime soon.
So magmatic means just molten rock. Magmatic,
Yes.
that's the verb, or no, the adjective.
Yeah, it's like if you have a lava lamp above the surface, it's a lava lamp. If you put it below the surface, it's a magma lamp. So magma
Yes.
below, lava above. That's
Very
the
good.
only difference.
Okay. Interesting. So magma that's hit the surface, it has a new name, even though it's the same stuff.
Yeah, I mean, it does change because now it's at atmospheric pressure. So it starts to crystallize and cool down, and it releases a lot more gas very quickly. So there are changes, but it's the same stuff.
Oh, okay. I never thought about that. Okay.
Yeah,
so you
it's
wouldn't
really
speak of
fun talking about the
you
vents.
wouldn't speak of magma rivers flowing down a volcano. Those are lava rivers that moments ago were magma coming up out of the caldera.
Yes.
Okay.
And do you sell magma hats? Because I've been trying to get one for a long time. I just want one of those magma hats. I love them so much.
Might have to make them black like the rock once it's cooled down instead of red.
You had me at black, Janine.
And I wanted to
Beautiful
make
color.
fun of the fact that you had two different words, but in my world, we have three different words for the same thing, right? So there's an asteroid moving through space. If it's visible as it descends through the atmosphere, then it's a meteor. And then after it hits the ground and you pick it up, it's a meteorite.
Right. Yeah.
Yeah, same damn thing.
And it's all the same thing.
Same damn thing. Yeah.
You
I like to
guys,
be confusing.
well, yeah, they're very complicated, these astrophysicists, you know.
So let's start with questions. This must have been a very fertile topic, because who doesn't think about volcanoes in our lives?
Without a doubt. Yeah.
You all should every day.
So you know what we normally do? We go out to our various incarnations on the internet and we ask people to send in their inquiries. We always start with the Patreon patron because they give us money. And quite frankly, we love that transaction. It's a lovely transaction.
Chuck, we need a less crass way to communicate this information.
That's why I love it so much. Anyway, here we go. So let's start with Christopher Zappel on Patreon. And he asked, are there any new developments with the super volcano under Yellowstone? And I will add to Christopher's question as an addendum. What is the super volcano under Yellowstone?
So, Janine, what's up with a super volcano?
I should have placed a bet that this would be the first question. I knew it was coming. So supervolcano is actually a word I don't like. It's a word that means a volcano that can produce these largest style of eruptions, what we have a VEI, or Volcano Explosivity Index, which goes from smaller eruptions to the biggest of the big. So this has been coined a super eruption, the biggest style of eruption. And a supervolcano is a volcano that can produce a super eruption. Yellowstone has produced 2 of these in its entire history. So while it may never do one again, and at the moment there's no signs that it even has enough magma to do that anytime soon, it's just a word that says that it's capable, because it has in the past, of producing these very large eruptions. As far as new developments go, people are always trying to learn more about this volcano, basically getting more understanding of the subsurface, of the geothermal system, which is not really related to the subsurface. The Yellowstone Volcano Observatory, which is part USGS, part universities, part other organizations.
So
constantly
USGS,
monitoring
United
it.
States Geological Survey.
Yes,
USGS,
that is correct. Yeah, but it's not just them. It's a group of organizations that are monitoring this volcano and constantly looking at the geology to understand what style of eruptions have happened before, and therefore what it might do in the future.
Wait. So when was the last eruption? How long ago?
The last eruption, I think, Yellowstone, the last eruption was about 70,000 years ago, and that was just a lava flow. In fact, the last 50 eruptions at Yellowstone, most of them have just been lava flows.
In other words, it's just the potential for the eruption. It's not, that's it. Just, it could. I mean, that's like.
It has.
It has, and therefore it could. Or
Maybe.
Wait, Janine, just admit it. Say, we have no idea.
yeah, because I'm going to say, that's not a really, It's just not a really good like descriptor, because it's like me saying I'm a super dad. I never met my kids. I don't play child support, but I could.
You might have once or twice.
I
don't like that at all. I think it's not a good name. I agree with you completely.
Okay.
So it just means it has in the past. Most of the eruptions are much, much smaller, but it's become it's like the adult version of the monster under the bed at this point.
Gotcha. All right. Okay, let's move on.
Next question.
Let's go to Christopher Fowler. Dr. Tyson and Dr. Krippner, in regards to volcanic emissions and climate change, does volcanic activity release more greenhouse gases to the atmosphere than human activity? Now, climate obfuscators often cite volcanic activity as one of the main contributors to greenhouse gases on Earth. So
Janine, where do volcanoes fit in the equation, in the greenhouse equation?
So looking at carbon dioxide alone, which as we know is a very large culprit, humans release through fossil fuels and other activities 40 to 100 times more than all volcanoes. So under the ocean and on land. There's a huge program, the Deep Carbon Observatory, that's been actually looking into this. And no, we are releasing so much more than volcanoes.
So volcanoes are not the problem. They shouldn't even be part of the conversation, because they're going to do what they're going to do anyway, right?
They are. They helped us get our atmosphere in the beginning, and they're a very important part of the natural carbon cycle and our atmosphere and all these nutrients. But as far as what we're seeing now with climate change or global warming or whatever you want to call it, they are not the culprit. We are.
Let me invert the question. So if you could find a way to tap a volcano, releasing some of the gas pressure so that it never blows, and maybe use the energy from that tapping process to drive the power needs of a city that might otherwise be leveled under a lava slide. You're saying that's not good for the greater balance of the Earth's ecosystem, because Earth needs some rate of volcanoes to sustain its balance? Is that a true statement?
Yeah, I think so. I mean, not that we can't stop eruptions. That's something we cannot do. We are so tiny on the scale of these enormous, enormous systems. But they're a hugely important part of life on this planet, for life, for soils, for the atmosphere, for nutrients. So no, we shouldn't be stopping them. That's just what our planet does. That is part of us living here. When it happens, when people are involved, of course, that's heartbreaking and devastating, but it is something that we have to live with.
I just love the fact that Neil deGrasse Tyson turned into a Bond villain just then.
He did, right?
It's just
let's kill the volcanoes.
That's very cool.
Yeah, be careful what you wish for, right? If you get rid of all the volcanoes, something else happens down the line.
2020, please stop saying stuff like that.
All right.
All right, Chuck, great. One more question before we go to break.
Okay. All right. I love this. This is Karen Netherland from Facebook. And Karen says, hi, this question is from Jackson, who is 6 years old. Jackson would like to know, why do volcanoes explode? Ooh.
That's a really good question.
Yeah, we actually don't have time to get to Jackson's question right now. But when we return, we will find out why volcanoes blow in the first place on StarTalk. StarTalk, we're back. Cosmic Queries, the volcano edition of Cosmic Queries. I got Chuck Nice, as always. Chuck.
Yes, sir. Yes, sir.
And we have our volcano expert. They do exist in this world. Janine Krippner. Janine works for Smithsonian. And if you heard our first segment, you caught a little bit of an accent in her. And you hail from originally where, Janine?
New Zealand. And when I'm in New Zealand, my accent is much stronger, I promise.
So thanks for tamping it down for us so we can understand your English.
You're welcome.
I visited New Zealand a couple of years ago. It's a beautiful place, and I would return in a heartbeat. And, of course, I visited Hobbiton. And the whole family went. My son he wanted to move there. He just wanted to live in Hobbiton.
I don't blame him. That's actually just sort of up the road from where I live. It's a beautiful place to be living.
Whoa. Very cool. Very cool. So, Chuck, we left off with a question from a 6-year-old kid named Jackson. And what was that
That's
question?
right. And Jackson wanted to know, why do volcanoes explode?
Back to basics. Janine, what do you have for us?
That's a really great question. So once we get magma high enough, down way deep down below, magma is rising towards the surface because it's less dense than the rock around it. So if you pour oil into water, the oil rises because it's less dense. Same thing. Once you get it closer to the surface, that magma has a lot of gas in it, very, very gassy stuff, a whole lot of different kinds of gas.
Chuck is gassy all the time, I've noticed.
I hope you're okay with that.
Well, it's because I eat a lot of vegetables. That's all.
Oh, good. It's healthy. I'm just glad we're on Zoom right now and not in the same room.
Well, thanks for playing along there, Janine.
Okay, go on.
So volcanoes can be just as dangerous, if not more. Once you get them closer to the surface, there's less pressure because there's less rock on top of the magma. Everything's being pulled down because of gravity. So that pressure is reducing. So if you think of a bottle of soda, when you get it straight out of the store, you can't see the gas. You know there's gas in it, but that gas is under pressure. It's inside the liquid. It's in solution. Once you take the cap off, that's releasing the pressure and that gas can start to come out. If you shake it up and take the cap off, that's essentially what an explosive volcanic eruption is. You have this gas coming out so quickly that it's violently ripping apart the fluid, or in this case, the magma or the rock.
So that's why it's not just a single pop. It's not just a single amount of pressure trying to pop a lid. It's once that does pop, all these gases now want to continue coming out.
Yeah. It can be a bit of what we think can happen is it can be a wave that goes down that conduit of the magma. Once you have a more of an open system, so it's already made its way to the surface, you can have more discrete eruptions or explosions. We call those volcanian. Or if you have runnier magma, you can get strombolian eruptions. But yeah, if you have the magma coming up, it hasn't erupted yet, it's essentially like shaking up a bottle of Coke and taking the lid off.
So you've classified types of eruptions.
Yes,
I mean,
so volcanian is where you have these volcanic ash plumes, and volcanic ash is not smoke. It is pulverized volcanic rock and gases. So that's when you have an ash plume that comes out and then it detaches eventually. And then you range up to your very large eruptions, which we call Plinian, which is from the Vesuvius 79 AD eruption, but named after Pliny the Elder, who was there. And scaling it back to the other end, when we have runnier magmas, we have strombolian eruptions, we have Hawaiian eruptions, which is what we saw in Hawaii when that was still erupting.
I was going to guess that. I was going to guess that.
Oh, good guess.
The Hawaiian eruptions, yeah.
But we do have plenty of other types of eruptions too, but those are the main ones.
Okay, all right, cool. So we tell Jackson it's like open up a bottle of soda.
Outside, please.
Outside, after you shake it.
After you shake it.
That's popping the cap on a... Before we get to our next question, Janine, when I visited New Zealand not too long ago, just a couple of years ago, I visited Christchurch, and they were still recovering from a major earthquake that had occurred there. And I'm just wondering, does proximity to geologic activity enhance people's interest to want to study it?
Well, I always loved volcanoes. I'm pretty sure I was born that way. I don't remember when I started, but I'm the only person that I know of from my hometown who's a volcanologist. So while I'm sure it does in some ways, we have an extremely active geologic country in New Zealand. We're actually on a major plate boundary, but the plate boundary changes. It's a subduction zone in the North Island, and that's more of a sort of, it's a mountain building zone in the South Island, and then there's a weird transition zone in the middle, and then in the North Island we're also rifting apart. So it's a very complicated region. We have the potential for a lot of different eruption centers, as well as earthquakes and tsunamis and landslides and all
and they're all related. I mean, the moving plates, the existence of volcanoes, tsunamis, it's all a family of Earth getting pissed off.
Oh yeah, big heavy family.
Now, if you wanted to be a volcanologist from very early on, you still have your eyebrows. So it seems to me you would lose those every time you leaned into a volcano to look in.
Oh, these are painted on.
Okay, that's the answer. Okay.
I've only nearly lost eyebrows or arm hair once, but no, I haven't leaned over a crater looking into lava yet. So I'll let you know the eyebrow status after that.
Gotcha. I want a full report.
I'll let you know.
All right, Chuck, what else you have?
Yeah, that's pretty good. Actually, that kind of, it's a perfect segue into the digital addicts from Instagram. His question, or her question, not sure, says, "Hey, Neil, big fan here, and hey, Janine. Everybody seems to be asking about the volcanoes themselves, but I'm more interested in the equipment. What ways are there to analyze volcanoes, and how far can we reach into a volcano? Thanks, love StarTalk," and I'll just say thank you to his last statement because it was a compliment, but I don't need to actually say it. But
withholding compliments from you.
Yes, I'm withholding compliments from myself.
Okay, that yourself too. So Janine, are you in full moon suit when you go into calderas? What's your standard equipment?
So going into calderas, I should probably say the difference between a crater and a caldera. So going into a crater, which I've done, it did not have lava in it. Most of them don't have lava in it. Versus a caldera, you mentioned you've been to Yellowstone. So all of that area within the park is the caldera. It's just so big you can't see it. But if you are sampling lava, you can have that spacesuit looking thing, which is basically to protect you from the heat if you have to be there long enough. But if you run up, grab a sample of lava, run away again, there was some great footage of people doing that with their 2018 kilowatt eruption. You don't need that suit. You just need to be quick. Our technology
By the way, I noticed
ranges...
that I visited Vesuvius in Italy, and that thing, I don't know when it last erupted, if not Pompeii, but I didn't see any lava, but it was hot. It was hot. I went down there to get a closer picture. I said, I can't get any closer. And nothing was glowing. Nothing was flowing. So I felt like the really inadequate stuff, like I would never be a volcanologist.
No, probably not. You're not tough enough for
Oh, man.
I'm just sorry.
Man.
I have been in a lava tube that was so hot my eyeballs were drying out. That's the hottest I've been near. And that was 2-year-old lava. So it was mostly cool and solidified at that point. But no, they can get very dangerously hot. So floor is lava, not a good game, ever.
So you do have a special equipment. Do you have do you stuff to rappel down the side of the wall? That sort of stuff too, like mountain climbing things?
Yeah, depending on the type of fieldwork you're doing. So there's a huge range in fieldwork, whether you're collecting rock samples, whether you're collecting gas, whether you're mapping everything that's around there, whether you're looking at temperature, there are so many different things to do on a volcano, and each one of them is their own specialty. So
it seems to me everything you just said can be done with drones and robots.
No.
Ooh.
You cannot replace us with robots.
Okay, now wait a minute.
You.
But Janine, you got to qualify that. I mean, that's like me saying, no, a robot cannot tell jokes.
You don't want the robot to tell jokes.
I don't want the robot to tell jokes, but robots can tell jokes. So why could you not replace you with the robot?
Well, I got one. What college did the robot go to?
What college did the robot go to?
Solid State University.
That could also be a geology joke.
Uh-huh.
A bad one. So there are a lot of things that we need to see in the field for ourselves. So when we're going out there, we're basically looking at everything around us to try and understand what this volcano has done before. So if you have a drone and it takes even high resolution photographs, or even if it gets samples, which would be very time consuming, and we do use drones when it's dangerous. There are absolutely good uses for drones, but there's so much more that we can do as humans with all of the experience that we have, knowing what to look at when you have this huge area. Even in a crater, craters are really, really big. You said you looked into Vesuvius. That's, they get much, much bigger than that, and we are tiny if you look at photos of people on craters. So there are more there's much more analytical thinking that we can do with our experience instead of sitting in a drone saying, look at that, go look at that, get that sample. And things like collecting gas, you need to get it at the vent in a lot of cases. You can get samples using drones higher up, but by then you have the gases are diffusing. And so drones are absolutely useful, but it's still very important that we get in the field as well.
Chuck, sounds to me like Janine wants to keep her job. I
really like my field. You're welcome to come and tell jokes. I'll laugh.
Sounds good. All right. Let us move on to. Uh, I, I just like the name. This is Du Russell. Okay. And Du Russell says from Instagram, can a mountain ever form into a volcano?
Well, a lot of volcanoes are mountains.
Right.
And if you have a mountain area that is a volcano, you can grow new cones, which some people might call a new volcano. If you're looking at mountain building ranges, often those are made of things like older granite or the areas that aren't really volcanically active. It might be more difficult to get a volcano to form there because the magma has to make its way through the subsurface and everything's under pressure down there. So it's going to find the easiest way to the surface. So while yes, it absolutely could, it really depends on the easiest way that the magma can get to the surface in that area.
So
the magnet is opportunistic, is what you're saying. Yeah.
Yes. I mean, it's already come all this way, like tens to hundreds of kilometers towards the surface.
Right. Yeah. So
Very
it's
hardworking.
But when it gets to that point, it's like, I can't do no more. I just can't. So I got you.
If you look at all the granite in the world, that's failed eruptions, technically. Granite is magma reservoirs that froze, that stopped, that didn't erupt and slowly crystallized below the surface. So if you look at granitic mountain chain ranges, all of that is a magma that never managed to make its streams as an eruption.
Isn't Mount Rushmore, what's Mount Rushmore made of?
I don't actually know. Sorry,
that's
showing my
from New
foreignness
Zealand.
in there.
Yes.
I think Mount Rushmore is made of American exceptionalism. That's
You're going to
right.
say hopes and dreams.
Hopes and dreams.
Hopes and dreams.
Lost dreams.
Right. All right.
Let's get one more before the break.
Okay, here we go. This is this is Diego Herrera from Instagram. He says, "Greetings from Colombia. How does the temperature?"
Is that what he says?
That's what he said. He said it just like that too.
That's how he said it.
Yeah, he said, "Greetings from Colombia." Anyway, he says, "How does the temperature distribution of flowing lava change as it comes out of the erupting volcano? Specifically, how long does it take for the lava to solidify?" So,
Janine, I've always wondered that because you see the lava come out. It looks like it's hardening in situ, right? For the part but then it breaks and keeps going. So, what's going on there as this thing is flowing but hardening at the same time?
Yeah, so that's a really good question. So first of all, starting out in Celsius, because again, sorry, from New Zealand, magma or lava at the very beginning coming out, the more sticky, more explosive style lavas we call rhyolites, those are around 800 degrees-ish. And then we go all the way through
800 degrees Celsius.
Yeah, Celsius.
That's like 1,000,000 degrees Fahrenheit.
Basically. Compared to us.
Wait, hang on.
I'm glad I have you here to convert for me. Yeah,
we're going to I got to take a quick break. We'll come back to learn more about the temperature of the lava that comes out of volcanoes when StarTalk returns. StarTalk, we're back. Cosmic Queries, the volcano edition. So we're learning about what happens to lava, magma becoming lava. Is it freezing? Is it flowing? What's it doing? And tell me that temperature that it is.
So
temperature takes to liquefy rock. What temperature is that?
So it depends on the rock. It depends on the composition of the rock. Your lower temperature compositions like rhyolite, around 800 degrees-ish, give or take a few hundred. When we're looking at our basaltic lavas, like a Kilauea, 1,000 to 1,200 degrees Celsius, so extremely hot.
Wow.
So when you have those lava flows, or across the entire range, all of it can form lava flows. When it comes out of the surface, as the crust is cooling very, very quickly, that's when it turns to black or gray of some kind very quickly. If you have a really thin lava flow, it will cool a lot faster. It can still take, I don't actually know, I'm going to guess days to weeks if it's a thinner lava flow of a few meters. You can get lava flows that are tens of meters, and those can take months to years.
wow.
So it really depends on how much lava you have, the thickness of the lava, and how much of it is coming out. But it can take a very, very long time.
It's amazing. Wow. Mm-hmm. Well, so this is cool then, because K Futch asked this. It's a perfect tie-in. If lava moves so slowly, Why is it so destructive? I mean, I guess, get out of the way is really not the way to
It's
handle
like in the
it.
cartoon. I never understood the cartoons where there's a ball rolling down the hill and they're just running away from the ball rather than just
And
stepping to the
side.
Never understood that.
Right.
That is very good hazards advice. Step away from the hill.
But is that because of these temperatures? Is that really the big, I mean, aside from the fact that you basically have slow moving rock that's going to consume whatever's in its path, but is it the temperature primarily that makes it so destructive and so dangerous?
Some of it is pretty quick. We saw that with the Fisher 8 Kilauea 2018 event. That was very rapidly moving lava. But even with the very small, slow-moving ones, you can usually outwalk lava, but it will bulldoze everything in its path. So if you have a town in the way, it's going to go through everything. But with the fast-moving lavas, it can destroy everything. It can create fires. It can have a lot of very dangerous gases coming off it, and it's also extremely hot. So there are a lot of hazards that are around lava flows.
Tell me about pyroclastic flow.
Oh, goody. Yeah, I will. So when you're talking about pyroclastic flows, lava flows are very slow. Pyroclastic flows are essentially these exploding rapid avalanches of solid rock and very hot gas that race down the volcano or away from the vent, very high speeds. You cannot outrun them, and they will destroy everything in their path. So they are like the nightmares of volcanoes, these things.
So is that like in the movies when you see the big cloud that goes down the side of the volcano first? That's the pyroclastic flow?
Yes, like Dante's Peak. They actually did a really good pyroclastic flow in Dante's Peak. So they're incredibly dangerous.
So that'll kill you too, even though it's not lava. Really it's very hot, and that'll kill you too.
Plenty of ways to die in a volcano.
When you say very hot, what's the temperature we're talking about? Am I going to get like burned alive? I mean, how exactly am I going to die? Am I going to be covered and encased in ash? Am I going to burn up and all my flesh is going to peel off? Or am I going to breathe?
This is more Chuck.
Am I going to choke to death? What's going to happen?
Okay. Janine, how will Chuck die?
Yeah, and I'm not talking about anybody else, Janine. I'm just talking about me.
We can have a longer conversation about this later if you'd like, but specifically with pyroclastic flows, the temperature is extremely dangerous. So if you do survive it, you're looking at intense third-degree burns over much of your body, especially anything that's exposed. You're looking at lung damage, especially if you're not wearing any kind of proper gas mask. So the damage to the lungs and the esophagus can be very dangerous as well. That can kill you. And you also have a lot of rocks. Unless you have a very gassy, gas-rich, low rock content pyroclastic flow, which we call a surge. If you have a very rocky kind of pyroclastic flow with a huge amount of solid rocks, they can be quite big too. These rocks can be the size of a car. Then the impact is very dangerous as well. So every part of these things is dangerous.
So, Chuck, you'll die 12 ways.
I was going to say, I'm just dying every way that I just asked. I'm dying
yes,
from
you
the inside
did.
out, outside in. I'm dying on every single level. Okay, all right. Good to know. Good to know.
You'll be doing a very efficient job.
All right, what more do you have? Chuck.
Okay. We kind of got to this, but I think we can get into it maybe a little deeper because it's a great question from Whoopsie Doodle on Twitter. And Whoopsie Doodle says, hi, Dr. Tyson and Janine. I would like to ask, what role does volcanoes play in our ecosystem, and what do they tell us about the Earth? We got into the ecosystem a little bit, but what are we learning about us and this planet from volcanoes?
There's a lot volcanoes can teach us. Like we can, as magma is coming up from very deep, especially hotspot volcanoes, which where we have mantle plumes coming up. So that's magma coming up, or at least hot rock coming up from very, very deep below. It can grab chunks of that rock and bring it up to the surface. So we can actually learn about the insides of our own planet that way. And
without having to dig.
You'd be digging a long time.
Yeah.
So yes, much more efficient. They also tell us about how our atmosphere formed. So looking at how our planet actually evolved. Looking at areas like geothermal areas can tell us how life evolved on this planet, and how like things like extremophiles, how they actually managed to survive in these areas. So there's a lot we can learn about our planet, how it's evolved through time, but also how we have evolved through time.
I think we also learn from metals that come out of volcanoes that harden with their magnetic domains aligned to Earth's magnetic field, it tells us that Earth's magnetic field has flipped. That was, I think, the earliest evidence of the flipping of Earth's magnetic field over the millennia.
Yeah, that can even help us understand when things erupted. So we can line those up with different polarities and understand the ages of eruption deposits.
Mm-hmm. Man, she really wants to stay employed. That's what it sounds like.
You need me.
She loving her job.
I love it.
Okay. All right, what else, Chuck?
Love it. All right, this is Angry Scientist at Erudition of Life. Erudition Life on Twitter says, the light produced by magma and lava, is that red hot glow or brightness because of photons? And does the magma and lava create their own photons? So it's light that we see coming from it. Would that be?
Yeah.
Is that the same light?
I can take this one, Janine. If you
can try, yeah.
Yes.
I'll let you answer a volcano question on your own show. Go for it.
Yes is the answer. No, it's very simple. Everything, even at room temperature, is emitting infrared light, but your eyes are not sensitive to that. So when you turn out all the lights, you can't see anything. But you can take out an infrared camera and it can see which things are slightly warmer than others. If you keep raising the temperature, okay, they become more and more visible to the infrared camera. Eventually, the glowing object no longer only emits infrared, it'll begin to emit red light. And this is what happens if you have an electric stove. If you put it on low, you don't see it. If you turn out the lights, put it a little higher, it begins to glow red. And the temperature at which things glow red, that's up around the 1,000 degrees Celsius that Janine was talking about. If you want to raise the temperature some more, it'll glow white hot. And I don't think magma gets to white hot. Does it, Janine? I don't think it gets
we get
that.
Yellows.
You get some yellows. Okay. Yeah. And so in transitioning to white hot, you go through a yellow hot phase. And then the hottest of all hots is glowing blue hot. But apparently you're melting these rocks at red hot. So we're good to go there.
Yeah, you can get burning gases that come out blue.
So that's great. And they're for a different reason. It's not because they're thermally glowing blue. It's because they're emitting blue light specifically. Yeah. But yeah, they're photons. They're actual photons being given. And it's no different from the photons of an electric stove that's on high. Yeah.
Oh, I rate you a 10 out of 10 for that volcano answer. Good job.
Oh, well, thank you. Thank you. I get an honorary volcanologist. Right.
Okay. This is Irene Polly, plug-in Polly, actually, from Facebook. She says, greeting doctors. Here is that kind of left me out. Here is one question for you guys. How many dormant volcanoes with potential to cause, now here's the qualifier, mass devastation are there here on Earth? So that excludes a lot.
What's the definition, Janine? What's the definition of dormant?
Dormant, I would say, is something that hasn't erupted recently, but really, we don't really have like this is what dormant is, this is what active is.
Okay, what does recently mean to you? Is it 10 years, 100 years, 1,000 years?
Well, we call a volcano actively erupting if something hasn't, generally, there are exceptions to this, but generally if it hasn't erupted within 3 months. So after that 3-month mark is when we go, okay, it can be considered not actively erupting now. But you can still have active systems. So we have a few crossover terms there. But I think the important thing there is how devastating are we talking about? So I see a lot of questions about, can we wipe out life on Earth? No. But devastating can be extremely devastating with a much smaller eruption if you have a city on the flank of the volcano.
Ooh, like Pompeii, for example.
Like Pompeii, exactly. And there are some cities living in volcanoes, like Camp Flegrei, right next to Pompeii. So, but if you're talking about like impacting a large area, I don't know how many we have. So we could look at how many we know that have erupted, those large-scale eruptions. I don't know the number for that either. But that doesn't say that volcanoes that we know now that haven't done that in the past might not do that in the future. So there have been some volcanoes that people didn't even really know were volcanoes before they produced extremely large eruptions. And Pinatubo in the Philippines in 1991 was kind of an example of that, was the locals didn't really see it as a volcano. It was just like a low-lying hill. And then it had the second largest eruption of the last century. So good question. Don't know the answer.
By the way, during Pinatubo, I had observing time allocated for me completing my PhD thesis in Chile, in the Andes Mountains, and Pinatubo's ash crossing the Pacific Ocean interfered with my observations through the telescope. The quality, the transmissivity of the air of this starlight that's been coming from the center of the galaxy for 30,000 years, and it's got to slam into Pinatubo ash. Pissed me off.
F you, Pinatubo. Okay.
It's Janine's fault. Okay.
Yeah, I was totally in charge of that back then.
That's so funny. Well, there you go, Irene. By the way, Irene is coming from Helsinki, Finland. Just wanted to let you know. And she also gave me a friendly little troll by saying, "Chuck, my name is pronounced Irene." So there you go.
Irene. Yeah, helping you out, Chuck.
No, she's mocking me. Neil, she's mocking me. Her name is Irene.
Oh, she's mocking me.
Yeah, she's totally mocking me, man.
Oh, okay, fine.
Does that happen a lot?
What's that?
Does that happen a lot?
Yeah, Chuck is still learning how to read.
Yeah,
that's the problem.
Listen, I think as a person who has suffered tremendous head trauma all my life, that I do a fantastic job reading these names and questions, okay?
You've done great. I'm proud of you.
Okay.
We might have time for, I think, just one more question, Chuck.
Oh, wow. Okay.
What do you have?
Okay, here we go. This is Hussein. That ain't right. From Hussein says from Twitter, if this ever happened, or has this ever happened, and if it does, how much are we prepared for a super eruption that would cause global darkness for months? First of all, is that possible? That's not here, but one, is that possible? Two, would there be any contingency plans for something like that?
So as far as a volcanic eruption, there's a lot of misunderstandings about that. So Yellowstone is usually one people refer to as saying that would destroy the entire United States. But with the recent very large ones we've seen, where I am in DC, we'd get about a centimeter or less of volcanic ash. So this wouldn't cause darkness around the world. That's not what blocks out the solar radiation. That's the gases. And as you pointed out, those can reduce visibility, but not cause darkness. As far as how prepared we are, that's a complicated question, because in volcanology, what we do is we learn as much about volcanoes as we can to understand what they've done, and therefore what they might do and where they might do it. We also put a lot of effort into volcano monitoring using technology and building experience to understand when volcanoes start giving us signals that, hey, I might be doing something soon.
Right, because you're not useful to us unless you can make an accurate prediction.
You need us, but we don't do accurate predictions.
You need us, but we're not useful at all.
We are very useful, excuse me. We give forecasts. So just like the weather, who they're not going to say like it's going to rain over your house at 3 p.m. on Friday.
It'd be nice if they could, yeah.
Come on. Meteorologists are my friends, be nice. So we say like we might have an eruption of this style or this big within this amount of time, which is incredibly important, and this saves lives. Now, as far as is society ready, that's not a volcanology question. That's a political question, that's a community question, and you can look at some of the big disasters we've had recently, even the pandemic, and say, with all the knowledge that we have we been prepared?
Okay.
Well, so let me go out with this slightly nuanced version of that question. If you say this could blow any minute between now and 10 years from now, and okay, that's not very precise, but suppose 10 years go by and it doesn't blow, do you lose credibility to people who are trying to make business decisions on statements that you make?
That's a big problem. And generally, if you're going to have unrest that's that long, the longer time goes, the more information we're getting. We're getting more information, the more we're monitoring it. So we're going to understand more what might happen. But you absolutely have volcanoes that are magma is actually moving towards the surface, and then it slows down and it stops, and then it moves again and then it stops. And this can go on for weeks or months. So it's really important for us to communicate and have people understand the uncertainty. The magma could be racing towards the surface, and if it keeps going the way it is, it could produce a very large eruption. But that can slow down, it can stop, and not all of that magma can erupt. So it's a constantly evolving system. But yeah.
So people need to know that so they can work along with you when you make your best guess prediction. Yes. Based on the data.
Well, I'm not going to say guess.
I'm sorry, your best estimate is forecast. Fine, thank you.
Yes, and it saves a lot of lives doing that. Knowing when people need to evacuate, we don't want people evacuating and not living in their homes for weeks or months of the year. That's horrible. We want to help people, not harm them. But getting them out of the way in time, not getting them out of the way might kill them. Mm-hmm. So no, it's a very difficult area of helping communities is when do you evacuate? When do you tell people like this might happen? And we are very, we tell people everything and we know as soon as we know it, and we get more information that updates constantly. Just like this pandemic, our information has been changing, and our estimates of what might happen has been changing the more data that we get. And that's with any scientific field.
And the public, of course, wants a level of certainty that rarely the scientist can ascend to.
Yes.
So,
and sometimes we can. Sometimes we can say this is probably going to erupt in the next day or the next hours, and it does. Mm-hmm. There's a lot of different things, like how well we know that particular volcano. They all have their own personality. How well we've been monitoring it to understand its background level of activity. So what's it normally doing when it's not erupting? The more we do that, the more we can understand when things are really ramping up or when they're changing.
We got to actually end it there. Janine, give me one last words of wisdom in one sentence that we can take with us and gives us hope.
That doesn't start with "you need me."
Oh, damn. Volcanoes are an incredibly beautiful, amazing, and important part of life on this planet. So it's up to us to learn how to live with them and how to keep safe when they decide to do what they're going to do.
Nice.
Beautiful.
That's lovely.
Love that.
So you need me.
Okay. Well, Janine Krippner, it's great to have you back on StarTalk and for this very important topic. And maybe we can tap you again for some more volcanic wisdom and contribute to the show. Chuck, always good to have you.
Always a pleasure.
All right, this has been StarTalk Cosmic Queries. Neil deGrasse Tyson here, bidding you to keep looking up.